This is a quick follow-up to two different blog posts. One that I had a while back, it looks like it was last updated mid-January, and talking about this parallel interface bus. This is a feature of the 65265 microcontroller that lets you interconnect, and really it appears to be intended really to be more of a slave device, maybe to some other type of processor, whether that's an Intel processor or something other. Really meant to be, I think, more of an I/O type of interface device. But my intention was to try to get it to work between a pair of 65265s. And so I spent a little bit of time just researching it, trying to understand how it works, doing some testing, and ultimately I was able to get that running. And I've got a series of videos here, but basically taking a little board that I've built that is pretty close to functionality to the Western Design Center's SXB for the 265. And what I've done is in this video here, actually I'll keep going, there's a third one where I have it up and working. So I've connected between my board and the WDC board, connecting the appropriate ports using this type of connectivity that you see right here. So connecting from one system on these pins to the other system on these pins. And I was able to get it to work just with these two little boards. Well, more recently, I've been working to build a pair of PCBs that basically connect together. And part of the functionality that I've been trying to get to is where I have a primary and a slave 265. And I do have this working now. So I do have these PCBs connected, working, and that's what I'm just going to show real briefly in this video. I'll real quick pull up the two projects. Really the connectivity is this type of thing that you see here, but I'll just point that out. And then I'll just show how it's working here. So I think I will jump over to two projects here. This is the primary board that I have, and maybe if I go to let's just go to a 3D view of this and I'll talk through this. And then maybe I will also pull up the secondary, which it doesn't look like I have that project open, so let me get the secondary project open up also. That's this AV project. Okay, so that's opening on my other screen. This is my primary board, or the rendering of it. What I've done is I've essentially created a connection between this board and then let me bring over this other project and go to its PCB. This is my slave board, or secondary, what I'm calling an AV or audio-visual board. And on this board, I have a connector that will connect to that primary board. And I'll just slide this over here like this for a second. But what you're going to see is that, the intention is that on this board back here, I use this connector to plug into this connector on the secondary board. And on the primary board, I am connecting from all of the appropriate parallel interface bus or PIB pins. There really are more on the left side of this than anything, and you can kind of see that here, that all of these traces I have routed up through resistors just in case I misconfigure and I've got two things outputting at the same time. Maybe that would dampen any issues I might run into, or allow me to desolder and maybe do something different if this was not the connection that I had really needed to do. But taking all of these appropriate port pins, going through these resistors, going out through this connector, going over to the other board, in through this connector then, and then basically routing that up to the appropriate pins up here. And you can see that you don't see those traces on the top or bottom, which means I've got them on a middle signal layer. These are 6-layer boards, so I have one signal layer in the middle, but that's where a lot of these are being routed. And I could verify that just coming over here, and you'll see that these are all green, just being routed from these pads up here down to the appropriate connectors down here. Now, something else on the primary that I've set up is this chip right here. This is a dual port static RAM that both microcontrollers can access. And if I go back to my blog post, just to use that picture for simplicity for a second, this microcontroller can talk to the other microcontroller through PIB. Plus, this controller and this controller can access this 2K of static RAM simultaneously. So really, one can be writing and the other one reading simultaneously. They can take turns writing, whatever it might be. And so that's something I'm going to use to supplement the parallel interface bus connection here between these two systems. And if you haven't been watching the series, the goal is that this is the kind of the brain of the system down here. And then I'm going to offload video and audio tasks to this board up here. So that's the idea of this. And if I'm looking at my primary board and I go in, I do have an interconnect that looks like this. And this is basically where I'm just saying, okay, I want this dual port static RAM. Logically, it's got two blocks to it, but this is one chip, one IC, kind of a left side, right side. So one side's going to connect to my main microcontroller. The other one is going to go to signals that go to the connector to the other board's microcontroller. And then this is how I interconnected, how I connected from my primary microcontroller to these signals on the AV or secondary microcontroller. And then this is the connector itself that is on the board. And then if I go to the other project and I look at the similar type of thing, I have an interconnect, and really it's just the connector, and it's going to pull in the appropriate signals from the other board and basically connect them through on up to whatever it is on this system, on the secondary system, whether it's addressing or something else, addressing data, whatever it might be. All of the different PIB connections that I also need besides address data to get to the dual port static RAM. So I have that, and in these two blog posts, I'm trying to work through this dual PCB, and I've made, in my opinion, pretty good progress with that. And one of the last things to test is this, can I really connect these boards together and get this PIB working? And then this video also is kind of an update back to this over here, where I had done this on the separate PCBs, but now I'm doing it on really the design that I've been working towards here for however long it's been. I guess if this post back here was maybe updated in January, so it's probably been going on. The date today is the 26th, so let's just say 6 weeks later, and I now have these two boards going. But let me show you what I have here on my system. On my computer, I am going to pull up two things. One is a capture of my VGA output, and another is a tera term. And I'm going to go ahead and clear that buffer just so I have a clear tera term there as we get going. Now, here's the system that I'm working on. Again, my primary, my secondary, and really what I'm going to point out, and I'll just use a pin here. Microcontroller goes through these resistors to this connector, to this connector, to this microcontroller. Both microcontrollers can access then this dual port static RAM right here. This system down here, I have a keyboard hooked up, and really that's it. I don't have any other peripherals connected, so it's power and keyboard. The PS2 keyboard that you see sitting here. And then I have these screens, of course, that I can work with for output. Then we come over to this top board, and there's always fuzz on the board. But on the top board, I've got power. I have a USB-C connection to my PC. That's what's going to show up in that tera term, whatever I output to that. I have an audio output that is split going to my PC for recording, and I did just connect up a little Bose speaker here. I was previously using just some little earbuds, and that was getting a bit annoying. So I've got this Bose speaker. I don't know if my headset will pick it up when it plays sounds, but you might hear that play some stuff during my boot process. And then I have my VGA output, and that's what this OBS capture window is showing, is that right now my capture device is not sensing any video, and that's because I have this powered off. I also have these little piezoelectric speakers that give me some progress on boot up. I have a little screen here that also tells me some progress on boot up on the bottom board. You're not going to be able to see that. I'm not trying to capture the contents of this screen during this video, but it's going to do some stuff that I've shown in previous videos, just as far as a power on self-test, and then get me kind of to a little operating system command prompt. But what I've set up to this point is I'm going to be able to turn on the system, and basically they're both going to go through their initialization process. And once everything is done, they'll be ready to start processing data from this system to this system. And what I'm going to do for processing is when I press a key, it's going to come in through the PS2. This system's going to process it, turn around, and then send that key data, the ASCII value, through PIB to the other microcontroller. That microcontroller then is going to write it out through the USB serial up here. So that's the intention, and so I'm going to go ahead and turn things on. Now, I did do a little tuning of voltage. So this, I know it shows 5.2, but the little device inside of this that reads the voltage isn't super accurate. But by the time I leave this, go through the connections, get onto my board, I'm at just over 5.0 volts, maybe 5.05. So that's about where I want it. And so you can kind of disregard that. And you will see I am up to maybe 700 milliamps to run this, 700 to 800, somewhere in there, to run both boards simultaneously. So let me turn this on. There's going to be a bunch of piezoelectric post beeps that I know my headset's not going to pick up. But basically, I'm going to let it run through its power on self-test. When these self-tests finish, there's going to be an LED over here. This is a P64 that I light up at the end of both of the power on boot sequences, in addition to audio cues that I'll be able to hear. So here goes power. Okay, so now I'm sitting here, and if I just point out a couple things during that process, I've got a bunch of delays. I'm intentionally having it kind of slow down on the startup process. But I am, from both boards, testing the secondary static RAM, the secondary flash ROM, and I'm testing the dual port static RAM over here. So this one tests it, and it shows that it passed over here on this little LCD, which again, I know you're not going to be able to read, but it does say that I have this dual port SRAM test pass. This one up here, no screen, and what I do instead is I'm doing some audibles. So I've got some tones play that are telling me that it's succeeded on the static RAM, the flash, and the dual port access and test over to this board. So both boards are seeing that dual port static RAM and able to access it just fine, which is great. So now I can use that 2K for sharing information directly between the microcontrollers. So now here's the test if I can now type something. So if I come into my keyboard and I say hello world, I obviously can't type. Let's try this again. Hello world. What you're seeing show up on the Terra term is those ASCII characters. So basically, as I was typing it, again, coming in through my PS2 circuit, being processed, that's all interrupt driven. It's then sending data over to the other microcontroller. That is interrupt driven. And then that is turning around and sending it out through the basically the USB serial. Now on boot, this primary does also control the reset of the upper board. So if I come down to my primary and I hit reset, you'll notice, and I'll press this in a second, that it is going to reset this board. And I can always tell because I can look at this LED that should always be lit if it's running the main loop. And I'll see it go through things here and I'll hear it, all of that. So I'm going to go ahead and hit reset down here. And then there I just saw it reset and is holding the top board in reset. The AV board is being held in reset until this one gets far enough to let it go into its PIB configuration. And then now that is booting up, going through the rest of the post. This top one's doing VGA output. You hear the audio. Hopefully that's coming through a little bit on the headphones. And then I'm back up. And again, I can maybe try to say hello world. And that is coming through just fine. So the keyboard's processing it here. It's writing it to this screen. It's writing it to this screen. It's sending it through PIB over to here and sending it out through the USB. And then you're seeing it show up here on TerraTerm. Now, I've previously shown the code on this, so I'm not going to really spend much time on it, but I will point out the way I have my current project set up. I have two directories, one for the primary, one for the secondary or AV board. They both have a PIB file. And so on the master, I've got the functionality to basically come in here and initialize the PIB. And then I have a send PIB, which is basically to send a byte of data. On the secondary, I have a PIB slave, same thing. I have the appropriate initialization for PIB. I have the IRQ handler, and that's it. Because what's going to happen is as the master, my primary, sends data through the PIB to the secondary AV board, it triggers an interrupt. The interrupt, really the 265 microcontroller has the built-in functionality to be a PIB slave. And then I process that. And the only thing I do to process it is I load up whatever was received and I send it out through my serial connection, which again was going to TerraTerm. So that is what I've added. The functionality is quite simple on the slave because the 265 is doing so much of it in hardware. On the primary, there is no hardware support for the master functionality, so you essentially have to bit bang that, and that's what I've done in this code. And again, it's not complicated. I just had to ultimately figure out what was the appropriate sequence. And I'm not going to say that what I have here is exactly right. I know it's working, and there's probably improvements I'm going to make to this as I move forward. And the PIB can do much more than I'm doing here. The PIB has multiple mailboxes you can put things into. I'm just using one mailbox, this PIRS7. And now that I have this pair of boards working, I will start experimenting with those other things. How can I send multiple bytes of data through that bus rapidly? For example, I think what I'm going to want to be able to do is send a command to the AV board. And that command might just say do something or process further commands or details from a certain address on the static RAM. So if I send over 3 bytes, and I might not even have to send 3, I might only need 2 bytes I send over, I can tell it an address to go fetch basically instructions, data, whatever it might be off of that 2K, and it can do it directly. So as an example, when I get into music here, I could be down here capturing keyboard input to build a song. I could be writing the song data to this dual port static RAM. And then at the end of it, I could press, let's say, enter on the keyboard, send a command over to the 265 up here and say, you've got a song sitting over here, go play it. And then it has the routine to load that up and play that song, a MIDI type song, out through these programmable sound generators. So this is really now finally connecting all of this together, that I have really the core of the functionality I've been looking for. A couple minor things left, but as far as hardware, like I mentioned in the last video, I need to get my real-time clock working. I don't think that's going to be a big deal. SD card is going to take a little bit more work. I already have code for SPI and SD card, but I do want to try to get FAT16 running on it. So we'll see if I can make it through that or not. And that's not going to be a quick thing. That's going to take a while, I think. But that might then open up this so that I can assemble or compile applications that I can put onto an SD card and then basically do a directory of that and then run those off of it. So that's a stretch goal and probably a little ways away, but I think it's reachable with this hardware setup that I've got right here. So I'm excited. This is a nice milestone for me, and I'm looking forward to continuing working on this, but now it's going to start to be less hardware unless I start adding expansion functionality through either of these expansion ports. So I've got one for the lower board, I've got one for the upper board. I had a previous video where I was doing some speech. That speech stuff, I was tapping into, functionality down here for one of the ports off this via. So I might want to have this go over to an expansion board. And there's some other things I want to do, maybe to expand this hardware, but I'm going to try to stick with this for the most part, other than some minor little expansion things off to the side. And I do need to add a joystick port, and I'm either going to do that up here on the secondary because I've got 32 GPIO up here that are unused that I could do something with sitting off of these programmable sound generators, or maybe I'll just do something through SPI. A lot of joysticks, like whatever it is, an NES type controller is pretty close to SPI anyways. So I might just be able to use one of these SPI ports with some, I don't know if I have to put any, I'll have to put something in between those and the actual controller, but I think I can control one of those controllers through SPI here and have it be interrupt driven. But that would give me a joystick. I would have my video, I'd have my sound, really all the pieces that I could start assembling some type of program that does something maybe fun. So I think that's where I'm going to shut things down for this video. I think real-time clock is the next thing, and then I've just got a tremendous amount of assembly code. The functionality of the operating system down here, I've got to decide what do I want to put onto this upper board, and really what functionality do I want to support for the video and the audio that I would call from down here. But good enough for now. So again, thanks for following, and more to come.